There's there's a medium-sized walnut tree in my yard, and I want to cut the tree down. The tree leans into my neighbor's yard, and I want to tie a rope to it about here, and with two people, one person pulling on the rope and another person with a chainsaw, cut the tree down and pull it over such that it will go into my yard instead of into my neighbor's yard. And I have studied some physics, and I know that this is a vector problem. And there's a pretty simple model. The model is a stationary, like a log, that's leaning up against a vertical surface, or like a ladder or something like that. There are three forces on it. One of them is gravity down on the object. The other is the force horizontally at the top, which would be represented by the rope, and then the force of gravity. This is not a terribly difficult math problem, but I want to cut straight to the chase and go to the formula. The formula rather easily derives as the force on the rope is equal to the weight of the object times the cotangent of the angle. And notice that the angle that goes into the formula is not the exact angle of the ladder, but rather it's the angle up to the midpoint. So this is a fairly simple formula. We have the force is equal to the weight, which would be of the tree in this case, times the cotangent of the angles. So let's go back to the walnut tree. How much does the tree weigh? Well, I look around in my yard and I find a log that's 17.5 inches long, 12 inches in diameter. It weighs 60 pounds. I happen to know that the log I'm looking at is made out of oak, not walnut, but I figured that's good enough. It's 12 inches in diameter, which means it has a radius of 6 inches. So it weighs 60 pounds. It's 17.5 inches long. Well, 16 pounds divided by 17.5 tells us that it's 3.42 pounds per inch, and that looks about right. The tree I'm trying to cut down is a bit smaller. It's 10 inches in diameter, which means it has a radius of 5.5. So if my bigger branch is 3.42 pounds per inch, if I take that 3.2 pounds per inch and divide by the ratio of the squares, then I should be able to get the weight for the branch that I'm trying to pull down. So 3.42 times 5 squared divided by 6 squared gives us 2.3 pounds per inch. So the tree I'm trying to pull down is 2.3 pounds per inch. Well, how long is it? So I look at it and I say, let's call it 16 feet long, which is probably fudging a little bit longer than it really is, maybe quite a bit longer than it really is. This is an approximation, and I know that. But 16 feet will be 192 inches. So 192 inches times 2.3 pounds per inch tells us that the log that we're trying to pull with the rope weighs 441 pounds. By looking carefully at using some video tricks and looking carefully at the pictures I've taken, I've established that the angle is 82 degrees, and that's the theta angle that we're looking at is 82 degrees. The cotangent of 82 degrees is 0.14, and the force, F1, the force on the rope, is the weight times the cotangent, which is 441 pounds, times 0.14, and I calculate that to be 61 pounds. 61 pounds it's realistic to pick up 61 pounds, but probably not realistic to pull that much.